Welcome to Java, typecasting with primitives. As was discussed earlier, there are some restrictions that occur when assigning values to different variable types. For example, you cannot assign a double value to an int variable. The compiler will throw an exception or error, possible loss of precision. In this example, int num1 is assigned 3.0. System.out.println num1. Error, found double, required int. Here is an example of this possible loss of precision exception. Even though we can clearly see that there will be no loss of the fractional part because it is 3.0, the compiler will not allow it. However, if you, the programmer, decide that you only want the whole number part of the value placed into the integer variable, and don't care that you lose the fractional part, you can override the compiler's ruling by casting the double as an int, like this: int cast 3.0. Output 3. Casting is a technique in programming that temporarily forces one type of data to behave like another, for the purposes of allowing non-typical assignment statements, ones that the compiler doesn't normally allow. Here's another example. Int I is assigned 65. Char A gets I. System.out.println A. Error message, found int required char. In this example, a char cannot receive an int for two reasons. Int values can possibly be negative, and a char always has positive values. Even though a char is a member of the integer family, it cannot directly receive any of the integer data types without casting. The second reason is int values use 32 bits of memory, whereas char values only use 16. Another reason why precision loss is possible. An int value far exceeds the range of the char value, and so the compiler objects when you try to do this. With a char cast, the int to char assignment statement is allowed. Int I is assigned 65, char A is assigned char cast I. System.out.println A, we show an uppercase A. Automatic typecasting. Earlier, we talked about the shortcut operators, plus equals, minus equals, and times equals. One interesting feature of these shortcuts is automatic casting, or auto-casting for short. See some examples of this on the next slide. Int I is assigned 65. Char A gets char cast I. The output produces an uppercase A. A plus equals 5. A now becomes 70. We output this and we get the letter F. A minus equals 4.4. We output again and it's back to the letter A. Here you can see that the char variable easily handles increments and decrements by an int and by a double without an explicit cast. This is because the cast is automatic due to the use of the shortcut operation.